so can you guys see my screen now?
Sir.
All right, so is my voice clear so far? Is it loud enough? Okay, great. All right, so uh, I have to apologize. I just remember 5 minutes ago that I wasn't able to publish your quiz number one. Okay, so your module one quiz supposedly was due today, but I did adjust the due date until tomorrow. Okay, so today is already June 29, so I adjusted the due date until tomorrow so that you guys can have uh, or you can take this one today or tomorrow. Okay, so including the module 2 quiz. So we have two quiz, which is due date tomorrow. Okay, so yeah, just answer that quiz before tomorrow. Okay, or before it will be due. Okay, and for your third quiz, so the due date of this one is July 2. So you guys have 3 more days. Yeah, 3 more days before the due date of this one. All right, and for the last week, so week number 3, so we're going to talk about module 4, actually module 4 only. And then for the module 5 and 6, this is actually already let's say 80% of the module 5 you guys already know this one. So we will not meet for the module 5 anymore. I'll give this one to you guys as your self-study module. Okay, the same with the module 6, though I'm pretty sure that 50% of this one you might be already familiar with. But the thing in here is you have to learn this one by yourself. Okay, so from the basics up to the end. So you're the one who's going to learn this one because one of your laboratory is about Microsoft Excel. Okay, so you're the ones going to explore your own Microsoft Excel. So it could be 2016, 2015, 2018, 2019. So any version will do. So I think even though your versions are different, so this one will still be fine. Okay, the algorithms, the way how to do it is still the same. Okay, so that Microsoft Excel is, I think, this lab number 6. Okay, so this is already your final laboratory, lab number 6. So the due date of this one is, okay, so oops, here. So the due dates of the lab number 5, lab number 6, module 4 quiz, and then module 5 quiz, okay, and then including the case study number 4 will be on July 10. Okay, so you guys have one more week, like 11 days before the due dates of those given activities. Okay, so yeah, then after that, your midterm exam already. Okay, so your midterm exam will be on this coming 15, 15, 10, 12, and then 13. So 10 is Saturday, and then 12 is Monday, and then 13 is Tuesday. So if we can finish everything as early as we can, let's say most of you are already done with the activities, then maybe we can have your midterm exam on this coming July 10th. Okay, so the earlier the better, I guess, so that just in case there are others who won't be able to take the midterm exam, then they still have the chance to take it on this coming Tuesday, okay, July 13th. Okay, so are we clear so far with that? Hello, hello. So if you guys haven't eat your breakfast yet, so feel free to eat it now. So you can eat while listening. You can drink your coffee while listening. So it's a lot better. All right. So yeah, we're almost done. So we are now on week 3 actually. Okay, even though we are still at week 2. Okay. All right. So that's only it for my additional announcement. So if you guys don't have a question anymore, then uh, we can start now. So the topic for today is Module 4 number systems. So in here, we're going to talk about the types of number system. So as you guys can see, we have five. The first one is decimal, second one is binary, third one is octal, hexadecimal, and then n-based system. So maybe you are already hearing about binary. Maybe some of you are already heard about decimal, okay? Or maybe heard of you already octal, hexadecimal. So in here, we're going to talk about them one by one, okay? And n-based system. So later on, I'll discuss what is this n-based system. Then after that, we'll discuss number conversion and operations, sign numbers, and then computer codes. Okay. All right. So without a further delay, let's now start with digital circuits. So when we see digital circuits, it is binary in nature, but several types of representations of numerical data are in use. Okay, so when we see binary, it's actually 0 and 1 only, but sometimes it's not only 0 and 1, okay, because we have other types of representations. Like, for example, an octal can contain a number of 0 to 7. A hexadecimal can contain a number 0 to 9, and then at the same time a letter A to F. Okay, so later on we'll discuss more about that. But here are the types of representation of unsigned integer number. Okay, so when we say unsigned, it's just simply a positive number. Okay, so if it's signed, then it is a representation of negative number. So we can have a positive binary or a negative binary. So we can have a positive octal or a negative octal. So the same with decimal or hexadecimal. But mostly, 80% all the time, we're always using unsigned integer. Okay, we don't use uh, sign number. Okay. All right. So let's start with decimal. So decimal number systems. So people use decimal representation to count. Okay. The one that you guys can see on your hand right now. So digit is derived from the Latin word for finger. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fingers. So since we have 10 fingers, so it uses 10 as a base. So it's very obvious. Okay, just look how many fingers you have. Well, unless you have an extra one, or you have, you're lacking one piece of your finger. So it's a different scenario already. But the default one is 10. Okay, so it is also called base 10 system. Okay, but take note, even though this one is a base 10, okay, it doesn't end up with 10. Okay, why? Because in computer, okay, we always start with 0. Okay, we count starting from 0 and then incrementing. Okay, depending on what number it will end to. So in here, if we have the base 10, so it's 0 to 9. Okay, not 1 to 10. Just take note on that one. Okay. And next one is binary number system. So basically, when we see binary, again, just like what I mentioned a while ago, it's just a representation of 0 and 1. Okay, so there are no other combinations numbers when we see binary. It's just 0 and 1. There is no way that you will have 2, 3, 4, 5, 6, 7, 8, 9. Okay, there is only 0 and 1 in binary. Okay, so that is one thing that you might want to memorize, or you might want to remember when it comes to binary number system. Okay, so basically, if it's a 0, then it's just off, and if it's 1, then it's on or turn on. Or in other words, we call this one uh, inactive, okay, or not active, and then 1 is active or it's activated. Okay, so yeah, that's basically the meaning of 0 and 1 in our binary. But before that, yeah, let's start with one character only. So lowest, okay, we call that 1 bit. Okay, so this is already the lowest representation of a number in a computer. So the one character that you guys are seeing right here is called a bit. So if we have two character, then we call that one 2 bits. If we have three character, then we call that one 3 bits. If we have four characters, then we call that one now 4 bits. And at the same time, we call that one nibble. Okay, so this might be new to you guys, but 4 bit is equal to 1 nibble. Okay, and then having 2 nibbles, okay, or 8 bits is already 1 byte. So maybe this is not the one that you are always hearing, especially right now. Like, started with bit, and then nibble, and then byte, and then kilobyte. and then megabyte, and then terabyte, and then petabyte, and so on and so on. Okay, so as of now, we only have petabyte, I guess. I'm not sure if there is already a larger size of that one, but mostly we only have terabyte nowadays. Okay, even megabyte maybe when it comes to phones storage, like 64 gigabyte, 128 gigabyte, 256. Okay, up to maybe 512 as a internal storage. So external storage is already a different scenario. So you can have up to 1 terabyte, I guess. Well, that's already super large when it comes to smartphones. Anyway, so after byte, okay, so having 2 bytes, which is equal to 16-bit, we call that one word. Okay, so this might be super new to you guys. Like, word? Is it literal meaning of word? So no, in computer we have this kind of size also. We call that one word, but we don't usually uh, say this one or use this one when it comes to storage capacity. We always stick with byte, kilobyte, and then megabyte. But yeah, just to let you know, so we also have this one. So 2 bytes is one word, and then 4 bytes is double word, or this one is equal to 32-bit. Okay, so here are the representations. So here is the lowest bit, and then here is the highest bit. Okay, so we have here the 1 byte, which is 8-bit. Okay, and then 2 bytes, which is one word, and then 4 byte, which is one double word. Okay, so are we clear so far? Were you guys able to follow? Hello, hello. So just give me a thumbs up if everything is clear, if everything is good, just to let me know that you're okay with that. Well, if you have a question like you wasn't able to understand one of the things that I'm saying, so feel free to raise your hand or just speak right away. Okay, just to ask that question of yours. Okay, so the nice one right here is the representation of our decimal in going to binary. So again, when we see decimal, okay, so it is 0 to 9 actually in here, but it could exceed up to 15. Okay, but this is not decimal anymore. This number right here is already considered as a hexadecimal. But anyway, uh, it could be still part of decimal since hexadecimal is a variation of a decimal. Okay, so for decimal, we have 0, 0, 0, 0. I guess it's very obvious. Okay, and then as you guys can see, we have 4-bit. Okay, that's the default number when it comes to forming a binary number. So even though we only have 0 and 1, but we still need to have a 4-bit character in binary. Okay, just to represent the decimal in a complete manner. So for the zeros, of course, it's a 0, 0, 0, 0. So I guess it's pretty obvious already. But for 1, we have 0, 0, 0, 1. And then for 2, we have 0, 0, 1, 0. So maybe at this point, you cannot get this one already anymore. So don't you worry. Let me explain this one. Okay, so in binary, okay, so the default count of binary characters is 4. Okay, so all in all, we have 4 characters. Okay, so of course, it is any combination that you can think of as long as it's a 0 and 1. So all of them have their own different values, of course, or different results. So like, for example, 0, 0, 0 right here. This one, oops, ayaw ng tab. I guess it's a lot easier if I'll just use Notepad. Okay, so let's have this 0, 0 right here. Okay, and then in decimal, this one is 0. Okay, and then maybe it's a lot better if decimal is right here. and then the binary combination is on the right side. Okay, and then for 1, it's being represented by 0001. So how did this happen? So if you are going to dissect every character of binary number, so let's say starting from the lowest bit, okay, so this one is represented by a number 1. Okay, so the second number, this second 0 right here, this is the second uh, lowest bit. So this one is represented by 2. Okay, the third one is represented by 4. Okay, and then the last one, the highest bit, okay, this one is represented by 8. Okay, so basically we have a pattern right here starting from 1, just keep on doubling. Okay, so the second one is 2, just multiply this one by 2, this one by 2, so 2 times 2 is 4, 2 times 4 is 8, and then if you have more, okay, so let's say you have more binary numbers right here, so you can also do that one. So let's say another 0 right here. Okay, and instead of 8, then this one now is 16. Okay, so there you go. So yung lang sa space dito. Okay, so basically it's just keep on doubling. So 8 times 2 is 16. So if you have more right here, then just double it again. And in here we now have 32. So 16 times 2 is 32. Okay, and so on and so forth. So that's basically it, the representation of binary, or from decimal to binary. Okay, so as you guys can see right here, if you need 1, just activate the number that you need. So 1. If you need 2, then just activate the 2. Okay, so 1, 2, 4, 8. And if you need, let me get this one instead. Okay, so if you need 3, so you have to activate the 2 and 1. So it's 0, 0, 1, 1. So again, this one is represented by 1 and this one is represented by 2. So 2 plus 1 is 3. Okay, so if you need 4, then activate 4 only. So it's being represented by 0, 1, 0, 0. Okay, so this one is represented by 1, 2, and then 4. Okay, so if it's deactivated, then it doesn't count its value. But if that number is activated, then you have to count that value, wherein, let's say this one is equal to 4. And if you need 5, it's being represented by 0, 1, 0, 1. So you need the 4 and the 1. Let's say if you want to activate 8, then it's being represented by 1, 0, 0, 0, since this one is already 8. If you need 9, then just activate this 1 right here. Okay, so 8 plus 1 is equal to 9. So if you need 15, then just activate everything. Okay, so 1 plus 2 is 3, plus 4 is 7, plus 8 is equal to 15. Okay, so did you guys get this one so far? And how did we convert this decimal into binary? Okay, so sir, what if I want to, let's say, have a 16? Okay, then no problem. Just have a 1 right here and then 0, 0, 0, 0. Okay, so this is already equal to 16. So 8 times 2, so this one now has a value of 16. If you want 32, then no problem also. So it's now 1, 0, 0, 0, 0, 0. So notice that I'm, separating the characters every 4. Okay, every 4 characters. So that's just a way, okay, for me to be able to read this one easily. Because if they are something like this, like they are continuously connected with each other, I would be having a hard time, to not let's say see if it's already up to 128 bit, if it's already 256, 512, 1024, and so on and so forth. So with that, you already know that this one is 8, and then this one is 64, and then this one is 128, etc., etc. All right, so that's it for the decimal to binary. And then we also have octal number system. So before in decimal, we have 10 base, right? In octal, it's pretty obvious also, since, from the word octal, we have 8 base or 8 numbering system. However, again, this one doesn't end with 8. Okay, since we are going to start with 0, so this one is being represented from 0 to 7 only. Okay, so to count in octal, the digits combine after reaching a count of 7. So we have 1 to 7, 10 to 17, 20 to 27, 30 to 37, and so on and so forth. So in octal, we don't have 8 and 9. Okay, so that's one thing that you guys need to take note. Once you reach the value of 8, it's already converted to 10. Once you reach the value of 9, it's already converted to 11. Okay, so 9 to 15 in decimal, 11 to 17 in octal. So if we have, let's say 16 right here, it's already 20 in octal, and so on and so forth. So just keep on counting and just keep on skipping the 8 and 9s. Okay, so 0 to 7 from decimal to octal is the same. Okay, however, in octal, again, as I mentioned a while ago, we doesn't have 8 and 9. So in decimal, if we have 8, in octal, it's already 10. Okay, so there is no other explanation for this one, but you just need to memorize that when it comes to octal, we don't have 8 and 9. Okay, so I think that's the easiest way for you to understand, how to represent decimal to octal. Okay, well, anyway, so let's have this one. Let's start with decimal first, and then let's have the octal. All right. So in decimal, we don't have a problem with decimal, so we can keep on counting as long as we're going to start with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and so on and so forth up to infinity. Okay, that's the default, you know, uh, arrangement. Okay, or how we count things in decimal. Okay. But for octal, okay, again, we need to skip 8 and 9. So still the same, how we count things. It's just that we need to skip 8 and 9. So we'll start with 0, 1, 2, 3, 4, 5, 6, 7. And then we don't have 8 and 9. So the next one right here is 10, 11, 12. Okay, let me just align this one. I go 11, 12, 13, 14, 15, 16, 17. Again, we don't have 8 and 9, so just skip 18 and 19. We'll jump uh, right to 20 after that. And then followed by 21, 22, 23, 24, and so on and so forth. Okay, this one is also, of course, up to infinity. Okay, so that's basically it when it comes to converting a decimal to octal, or how we count in octal. Okay. So, did you guys get the idea so far? Okay, so for now, you don't need to memorize, just at least familiarize or get the logic behind it. Okay, so I cannot explain anything more rather than skipping the number 8 and 9. So that's the only logic that you can get when it comes to octal. Okay, well, anyway, so yeah, that's representation for octal number system. The next one is hexadecimal. Okay, so this one is also under decimal. So if you guys are going to take a look at this one, hexa is a base of 16. But of course, since we always start with 0, so we only have up to 15. Okay, so 0 to 15 when it comes to decimal. However, when it comes to 10, 11, 12, 13, 14, 15, in hexadecimal, it is now being converted into a certain letter. Like for example, number 10 is already equal to A, 11 is already equal to B, 12 is equal to C, 13 is equal to D, and so on and so forth. So, sir, why do we have to do this one? Why do we have to convert 10 to A? Why can't we just have 10? Well, that's because in computer, our computer reads data every character. So this one won't be read as 10, but this one will be read as 0 and then 1. Okay, so those two are two separate characters. So as a remedy, we need to combine this one, or we need to have a representation wherein this one will be one character only. So that is why maybe this is the algorithm that they come up with, wherein 10 is equal to A. So once our computer uh, got a data which is equal to A, meaning that has a value of 10 in decimal. Okay? And then 11 is B, 12 is C, 13 is D, 14 is E, and then 15 is F. So are we clear so far on how, or why do we have A, B, C, D, E, F when it comes to representation of character in, in binary or in this number system? Hello, hello. Were you guys able to get that one so far? Yes. Um, so the question of Mr. Christopher is, hanggang 15 lang, sir? Well, if we're talking about hexadecimal, then definitely yes. Okay. But of course, you can exceed up to how many numbers you want. But when it comes to hexadecimal, we can have up to maximum of 15. Okay. But you can exceed on that one. That's still under hexadecimal. Okay, of course, that's a different counting again. So 0 to F is 15. And then once you exceed that one, then you're going to go back to 10 to 19, and then 1A to 1B to 1F. So for you to be able to see the difference, okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Just align this one, 8 and 9. So it is the same for 0 to 9 in decimal to hexadecimal. Okay. But for 10 to 15, it's now being represented by a certain character. We're going to start with A, B, C, D, E, and then F. Okay. Then after that, you have to go back to the start, okay, where the number ends. So in here, after 0 to 9, of course, after that is now 10. 10, 11, 12, 13, 14, up to 19. Okay, maybe it would be better if I'll just eliminate this one, and then let's have a number of up to 27, 28, 29, 30, 31, 32. So let's have up to 32. Okay, and then in here we have 14, 15, so it's 10 to 19. So basically you will see the like the arrangement right here. It's only 0 to 9. So in here it's only 10 to 19. 10 to 19, 17, 18, and then 19. Then after that, you have to continue now the letters. But instead of let's say G, H, I, G, and so on and so forth, just add a number right here. Okay, we're in. Of course, we're going to start with 1. So it's now 1A, followed by 1B, followed by 1C, 1D, 1E, and then 1F. Okay, let me just align this one again. All right, 28, 29, 30, 31. There you go. And then after that, of course, after the 1F, then you have to continue this one now. So after 19, it's now followed by 20. So 20 to 29, and then after that, it's now 2A, 2B, 2C, 2D, 2E, 2F, and so on and so forth. Okay, so for the octal, let's continue this one so that we can have a complete representation of decimal going to hexadecimal, and then decimal going to octal. So it's 25, 26, 27, so we don't have 8 and 9. So the next one is 30, 31, 32, 33, 34, 35, 36, 37. We don't have 8 and 9, so it's now 40. So let me just align this one again. There you go. Okay. So are we clear so far regarding with this one? When it comes to decimal to hexadecimal, decimal to octal, or vice versa, octal to decimal, and so on and so forth. So any other questions so far? Okay. Okay. All right. So that's the representation from decimal to hexadecimal. So here are the things that we can do. So we can convert binary to decimal, octal to decimal, hexadecimal to decimal, or n base to decimal. Basically any base. Okay, we can convert any base to a decimal. So here's the process. So to convert an integer number in any base to decimal, add all the products of each digit multiplied to its base in increasing power, starting from 0. And to convert a fractional number, so this one is whole number and then this one is fractional or decimal. In any base to decimal, add all the products of each digit, multiply to its base in decreasing power starting from -1. So I know that, if you're going to analyze this one and then understand this one right now, you're going to have a hard time unless you see an example. Okay, so here's the only thing that I could tell you guys when it comes to uh, converting any base decimal. So if it's whole number, then you should have an increasing power starting from 0. And if it's a decimal number, okay, or fractional number, then you should start with -1 and then it's a decreasing power. So -1, -2, -3, and so on and so forth. Okay. So for you to be able to appreciate this one, okay, let me show you guys the format. So we have here the whole number. Okay, so ABC is just any, just a variable. So it could be any number as long as it's a whole number. And then XYZ is representation for the fractional number or fractional part. Okay, so starting from this one right here, from the decimal or the point right here, so it's being separated by whole number and then the fractional number. So here's the whole number and then here's the fractional number. So as you guys can see, we started with 0 right here and then it's incrementing or increasing by 1. So 0, 1, and then 2. And then for the fractional number, okay, so we started with -1 and then it's now decreasing by 1 or -1. So -1, -2, and then -3. So if you have more right here, then it's now -4. The same with this one right here. If we have more number right here, then it's now 3, 4, 5, and so on and so forth. Okay, so that's basically it, the format on how to convert this any base into a decimal. Okay, and then just add everything, and then you will get the result where it's now the converted result from this base to the decimal. Okay, so are we clear so far?